In this practice, we'd like to calculate self-inductance of a toroidal solenoid. But first of all, we'd like to explain the self-inductance. We consider the coil. And the current is flowing. Total magnetic flux of a coil is given by N times pi sub B. This is N turn of coil. Is proportional to the current. And the proportional constant is given by L. This is self-inductance. So in this question, we'd like to find the self-inductance of the toroidal solenoid. But to solve the toroidal solenoid, we'd like to discover the magnetic field inside of a toroidal solenoid. Then we'd like to apply the Ampere's laws. Ampere's law said integrals of the magnetic field of the closed path is equal to mu naught times current enclosed by the closed path. So we'd like to consider the closed path of this one. This closed path. The direction is this direction. And then you can use a right hand rule. Right hand rule. To find out the directions of the positive direction of the current. You can use the right hand. Then this is directions to the board is a positive direction. Then current is flowing from the here to the this is current is flowing in this direction. And flowing, but in this to pass this direction, this is directed toward us. This is directed toward us. Directed toward us. Directed toward us. Then actually the directions of the magnetic field is actually, if we consider that this is the direction of the B, it becomes B R theta. R theta is the length of this path. B times R theta. And the current is always the opposite direction to the positive directions. Positive direction is toward the both, and the current is directed toward us. This is the minus mu sub 0. And then how many current is passing through? How many turns is n turns? And the per length is a total amount of length is 2 pi r. So n turns divided by 2 pi r. This is a unit of length. Turns per unit of the length. And then you have to multiply the r theta. So this means n over 2 pi r times r theta. Then you have a find out number of turns. Times current I. And if you look at both sides, r theta appears in the both sides, should be cancelled out. So magnetic field becomes negative mu sub 0 n I over 2 pi r. So this is the opposite directions. Actually, the magnetic field is directed the opposite direction. And then we just only consider the actually the magnitude is important. Actually, the magnetic field is directed. This is the direction of the magnetic field. Okay. Then we'd like to find the self-inductance. This self-inductance we'd like to discover. And the phi sub b, magnetic flux, is obtained B times A. So this becomes mu sub 0 n I A over 2 pi r. Then if you multiply the n, phi b becomes mu sub 0 n squares A over 2 pi r times I. And if you compare these two cases, actually this corresponds to the L. Self-inductance of a toroidal solenoid is given mu naught n squares A over 2 pi r. This is the answer to this practice.